Okay, so we're going to do a quick recording here to show you how WinLog is a highly configurable piece of software. So I'm not connected actually to my TechEdge device, but to show the basics. So this is a dashboard I use for tuning when I tune the car, when I'm doing tuning. And the reason I like this dashboard with all my sensor values over on the right hand side is because it allows me to have Tuner Pro up at the same exact time that I have this console up. A lot of times I work exactly like this. So then in Tuner Pro, I actually usually set it up like this, and I can sit over here and actually look at a fuel map and do live hit trace, and I can alter values in the map and instantly see my lambda changes in the WinLog window behind it. So that's why I really like WinLog a lot, is that it lets me lay out my sensor readings on the dashboard any way I want. Okay, so that's one approach. Now, what if I was using WinLog without Tuner Pro and I wanted to make more use of all of this real estate? Well, the cool thing about WinLog is you can open another dashboard that you may have configured, like Sal's full dash metric. Okay, and now I have a different dashboard that lets me view RPMs on the rotary gauge, miles per hour, lambda, degrees. Now, from here, let's explore a little bit on how you actually build these dashboards. So here's an example. Let's say I wanted to put a new gauge up here. All right. So I can go ahead and hit add, and I can say add a new meter. All right. Then I can pick the data source, which is from the TechEdge wideband, and say I wanted a new meter. Say I had a second wideband O2. I can pick another lambda, hit OK. I'm just going to hit OK just to show you. So there's my new meter. Then they're highly configurable. You can change all kinds of things in here, including the colors, and that's how you customize them to look like this. All right. If I want to add a different kind of device, like for instance I can add something as simple as a digital meter. Okay. And I can pick from the device I want, and I might want to pick up airflow, which I already have here, but I'm just showing you how it can easily be done. And I can bring that down there. Now I can then change its title if I wanted to call it anything. Okay, so that's what I like about it so much. Now you can move these around. You can grab the edges of them. You can make the gauges bigger or smaller. Okay, it's a little tricky to grab the edge, but when you get it, that's something I wish they worked out a little bit better. One more second here. There you go. See that? I can take this guy, make it any size I want. Okay? And that's how this was laid out. In addition to building these types of controls, you can also build a logging control like this that can log multiple sensor inputs on one graph. All right? So that's pretty powerful. Now, I'll show you, there's a few more little tricks in here. Under View, Device Configuration, you can now, this is the TechEdge. These are all the inputs that TechEdge offers. Depending on the TechEdge device you bought, you may or may not have access to some of these, right? But the point is you can have sample time, which is down along the bottom. If it's a single wideband controller, you have lambda 1, then you have lambda 2, RPM. This is a user input which you can configure. I'm going to show you this. This by default says user 1 volts. See how this one said user 3? I changed this so that I can read my airflow, which is what I have here in grams per minute. So let me show you exactly how that's done. If you click on the settings, you can change the field name to anything you want. So I called it airflow total. All right. Then down below you can create a map. You can define the input in volts. In this column is 0 volts, 0.5, 1, 1.5. You can make this as granular as you wish. And on the other side, you can put in so 0.5 volts equals 260 grams per minute. I kind of figured this out from my math calibration. All right. But the point here is that any input can be mapped to any scale you want. In my case was grams per minute, and I took my MAF calibration right from the MAF curve, 0 to 5 volts, and laid in the grams per minute. The other cool thing is you can actually, once you lay this out, you can export this so it remembers it, and you can use it again. So let me show you what I mean. Here's my imports. I got all kinds of gauge scales created. So that one there was airflow gauge in grams per minute. So it's this one. Now you'll see if I hit edit, this is the format. Okay, so once you fill it in, it remembers it. Okay, so then if I wanted it in liters per second, I have a different one. Okay, this is liters. All right, and so on. And then if I wanted to look at it in millivolts, well, this one's kind of more obvious. Basically 0 is 0, 0.1 is 100 millivolts, 0.2 is 200, and 2.9 is 2.9, and so on. And you can lay these out any way you want. So that's what I really like about WinLog. Okay, you can do the same thing with your cylinder head temps. Let me show you how that works. I already did the math and the calculation. I actually checked, right? I came up with the built-in cylinder head temp gauge on the Porsche 911 has 0 to 5 volts internally inside the ECU. Well, I did and came up with the curve for that for degree C. So if you open this up, you now know that 0 volts is 260 degrees C, and so very, very hot, right? So what happens is as temperature goes up, voltage goes down. All right, so this is 260. That's the extreme end of the scale. At the other end of the scale, at 4.5 volts, you're at minus 30 C. I didn't bother going any lower because I'm never going to really drop below that. And then I calibrated in everything else. This was actually done in a controlled environment where I actually heated the sensor partially in boiling water to find out the different values and the voltages. Okay, and basically I laid out my cylinder head temps in degrees C. The scale is here, and that's what is being used on this gauge. So let's just cancel out of here now that you get the basics. So say no. So this guy here, you can see this is the cylinder head temp, which I defined from user input number 2. Okay, and then once you have that, on this guy is what's got laid onto that. And then if you go back over to view device configuration, we can look at the cylinder head temp, which is here, click settings, and here's the values that I came up with. Okay, so very, very powerful, very much highly configurable. When you're done making changes to a dashboard like this, you also can lock down. So under the dash configuration, I can say, okay, now lock the gauge position so they can't be moved accidentally. All right, I'm going to leave them unlocked for now. I don't want to remember these over here. So what I can do now is I can just simply say open the dashboard again. It's asking me, do I want to save these changes? If I did, I save it as a pre-configured dashboard. I want to say nope, I'm not going to save them, and I'm going to go back to my metric tune one, because now I'm going to show you another really advanced feature that blows away pretty much anything in the competition. So a little bit advanced. You might not follow the concept exactly, but let me explain how it works. So if I know what the total airflow is in grams per minute, that means instantaneously how many grams of air am I flowing into the motor at that given time. If I know this, okay, I can then calculate a field called airflow per rev. Now why can I do that? Well, this is how much is being ingested, and WinLog already knows the RPMs. So these two inputs, actually these three inputs come right out of the DME, out of the ECU. So I know how fast the engine's rotating, and I know how much air is being ingested. If I divide this by the RPMs, I know how much air is being ingested per rev. This is a pretty much a gold standard that you'd like to know as well. So I don't really have an input airflow per rev. I can't fetch that out of the DME, but I can calculate it. So let me show you how that's done, and this is where WinLog really shines. So under view, if you go back into device configuration, and you click on the TechEdge. So this one is the TechEdge, but you can then install what we call the WinLog virtual driver. WinLog Virtual Driver then lets you define fields that whatever field you like, which can be mathematically composed from other fields you have coming from the TechEdge. So airflow total and RPM comes from TechEdge. Right, let's take a look at that. So in TechEdge, I have airflow total and I have RPM. But I want to make a new field called airflow per rev. So how that works is you click on settings, and in here you can add new fields. So let's take a look at this one I added called airflow per rev. Click edit. Now the way it works is there's a syntax, a macro language. So what I want to do is take the TechEdge input, right? So I could say add variable, and I can pick the TechEdge, and I pick the airflow total, right? When you do that, it automatically added this guy on the first. Then I say, okay, take the airflow total, divide it by the TechEdge RPM plus 1. Now why do I add 1? Well, it's to prevent a divide by 0, right? You never want to divide by 0, and when the engine's not running, the RPM will be 0, and the program will get a divide by 0 error. So to fix that, I just always add 1 to the RPM. Who cares? There's not much difference between 900 and 901 RPMs, and it prevents a catastrophic failure of divide by 0. So that's how this was created, all right? So this is pretty powerful. I haven't seen any other tools out there that let you do this. So I can build new fields, new gauge widgets that are composed mathematically from other inputs. Now, this isn't exactly one other thing where I was really headed with this is what I really wanted on the dashboard is injection pulse width in milliseconds. Now, this gets a little bit advanced and you have to understand the math. But if I know how much air is being ingested by the motor per rev, okay, and I know that the target air fuel ratio, or lambda, is going to be the target air fuel ratio. Let's say I want it to be 14.0. I can easily calculate the injection pulse width of the injector. I'm not going to get into all the math, but let's just take a look and see how did I do that. So under edit, now I took the airflow per rev. So consider what I'm doing here. Airflow per rev is already calculated from 2 other inputs, so it's already a calculated value. Now I'm taking this calculated value and using it to calculate yet another thing called injection width. So what you do is I take airflow per rev and divide it by 14.0, which is in the ballpark, the target air fuel ratio, and then divide it again by the delivery rate of the 6 injectors. Okay, I know that the 6 injectors can deliver this many grams of fuel per millisecond, per millisecond. So basically all we're doing here is I can actually run complex mathematical calculations like this to come up with injection pulse width in milliseconds. Now this is also a holy grail that a lot of times you want to know is what is your injection pulse width. Now this isn't spot on, right? It's not the point. The point is that it's close enough when I'm doing tuning and monitoring that at least I have something that's not normally available out of the ECU can easily be calculated if you understand the math. So this is pretty nice. Like I know that in this system the minimum injection pulse width is down around 1 millisecond and the maximum is around 9. So I can instantly, by just looking at what the injection pulse width is, I know what the load on the engine is. If I see 6 or 7 millisecond pulse widths, I know I'm in moderate to heavy load. If I see numbers up around 8 or 9 milliseconds, I know instantly that I'm under wide open throttle conditions or extremely heavy loads. And it's nice to know these things. So that was a real quick tour of how to set up dashboards. And then once you have them set up, you can just say File, Save the dashboard as, put it in your favorite directory where you keep all your configurations, and you have all these different dashboards. I'm not going to cover the advanced graph here, but this is yet another thing you can do. I just wanted to point out that you can build these nice digital gauges that look like this, or analog, needle style gauges you saw in the other one, and you can put them anywhere you want on the screen, size them any size you want, make the numbers as big as you want, as small as you want, and highly configure the conversion factors from 0 to 5 volts to the units you want to see on the screen. That concludes this demonstration.